Hello.
Hi, Taylor. How are you?
Good news.
Good. So, what do we got today?
Um, Today we're just doing trigonomic equations again, factoring.
Okay.
So the first one I have right here is sine x plus 2 equals 3.
Okay. What's the next line?
1 second. Actually, that's it. I just have to figure it out and then look at the unit circle.
Okay, so we're going from 0 to 2 pi.
Yes.
And what do I have to do to isolate x? What's the first step?
Subtract 2.
Okay. Now, if sine x equals 1, where does that occur in the unit circle?
That occurs on pi over 2. And that's it, unless there's a negative one.
That's correct. That's one of the few things that only has one answer in the unit circle. In other words, most of your equations are going to give you two answers because there's almost always two quadrants that the answer appears in. But when it's sine x equal 1, that's the only spot. When it's sine x equal minus 1, that's the only spot. So those two numbers are the only ones where you're only going to have one answer in the unit circle.
Okay. The next one is 4 secant x plus 8 equals 0.
Plus what?
Plus 8 equals 0.
8?
Yes.
Okay, so secant x is equal to what?
Shouldn't I subtract 8?
Subtract 8, divide by 4, what do you get?
Then that would be secant x equals negative 2.
Correct. Where is x? Where is secant of x? We're going to do this as the 3060. And that's 1 square root of 3, 2. And then this is going to be the 4545. And that's 1 square root of 2. So which angle is the secant of x equal to, well, first of all, 2. In other words, the way I like to do all trig problems is to figure out the absolute value first of all, then figure out which quadrant it has to be in based on its plus or minus sign.
Okay.
So first of all, what is the secant the reciprocal of?
Cosine.
Okay, so it's 1 over cosine. Where is the cosine equal to minus 1/2?
2 pi over 3.
Well, the first angle is this one right here, which is pi over 3. Okay, so in other words, I also like to do all trig problems by solving what the first quadrant angle is, and then just figuring out what the second, third, and fourth have to be. Okay, so secant of 60 degrees is the reciprocal of cosine, which means the secant of 60 degrees is 2 over 1. That's what we're looking for. So 60 degrees, pi over 3, is our angle. Now the question is which quadrants it's negative in.
Okay.
Which one?
So far I see right now is quadrant 2,
Okay.
3.
So what's the equivalent angle of pi over 3 in the second quadrant?
2 pi over 3.
Okay, what other quadrant is secant negative in?
And third quadrant, and that's 4 pi over 3.
Okay, and that's the way you want to do all of them. Now, there are 6 trig functions. I tend to only focus on the 3 that are on your calculator: sine, cosine, and tangent. The other 3, which are the reciprocals, secant, cosecant, and cotangent, you can always get by just finding the reciprocal on your calculator. But I tend to think as a 3 primary and 3 secondary. So when you give me a secant question, I'm going to look for cosine. Where is the cosine equal to 1/2? And that's the way I tend to do those problems. If you can think in terms of all 6 trig functions, more power to you. And
Okay.
feel free to do them that way. You don't have to translate them to what, 3 primary ones there are. I just find it easier that way. What kind of calculator do you use, Taylor?
1 second. I think it's like a scientific graphing calculator.
Well, it's probably either a TI-84 or a TI-Inspire, and it matters. It's the 84?
Yep, TI-84 plus C Silver Edition.
Right, but that means you only have these 3 trig functions as buttons: sine,
Yes.
cosine, and tangent. So
Correct.
if you want the cosecant, you got to do the reciprocal of the sine. If you want the secant, you got to do the reciprocal of the cosine. And if you want the cotangent, you got to do the reciprocal of the tangent. And that's the only way for you to get these. In other words, if I said, what's the cosecant of pi over 6, you would take the sine of pi over 6 and take the reciprocal of it.
Okay.
Some of the more advanced calculators, like the TI-Inspire, actually have all 6 functions. In other words, you hit trig and you get 6 choices. You actually get 12 choices because you get the inverse sine, the inverse cosine. In other words, you get the trig function and you get the inverse trig function.
Ah.
You know what I'm talking about when I say inverse trig function?
Yes, isn't that like for angles with a negative trig function?
Here, let's just talk about it for a second.
Okay.
If the sine of 30 degrees equals 1/2, by definition, the inverse sine of 1/2 equals 30 degrees. In other words, you switch the domain and range.
Okay.
By definition. Now, notice what's happening. When we take a trig function of an angle, we get a ratio. When we take an inverse trig function of a ratio, we get the angle. So if you're trying to solve for trig functions of angles, you're going to get ratios. But if you're looking to solve for an angle, you're going to use the inverse trig function. In other words, if I told you that's true, how would you solve for theta?
I could do opposite over hypotenuse. So
that means inverse
sine
trig function of 1/2 equals theta.
And that's how I find the angle.
Yeah, by putting this into your calculator. If you go ahead and do that. If you have your calculator in front of you,
Okay.
do inverse trig or inverse sine of 1/2, and it will give you 30 degrees.
Yes, I got it.
And
I got the same thing.
yeah, and it depends, of course, on whether you're in degrees or radians mode. You always have to know that. And it's very important because it can be very deceiving. If you happen to be in radians mode, it's not going to give you 0.5. And you won't.
Yeah, it messes up.
Yeah, you won't know it. So is all the inverse trig function R is solving for angles. In other words, trig solves for ratios, inverse trig functions solve for the angles. So if you know the ratio but you don't know the angle, you can figure it out by the inverse trig function. All right, what else you got? I don't want to get too far ahead of you. Although sometimes that can be helpful if you are a little ahead of the next lesson.
That's very true.
Yeah, no, it helps you to absorb the material better when you listen to your teacher lecture for an hour.
Yeah. 18 cosine x minus 9 square root of 3 equals 0.
Okay. So what's cosine of x equal to?
Would I add 9 root 3?
Yeah, I'm going to skip a step here, assuming you know how to solve that. You add 9 root 3 and then divide by 18.
Yes.
What's
Then
what's that simplify?
can I cross? It would be cosine x equals root 3 over 2.
Okay. In the unit circle, where does that occur? And I'll draw the only triangle that matters, the 30-60.
Pi over 6.
Correct. Well, cosine x equals root 3 over 2. Yeah, pi over 6. So that's the first quadrant angle. Where else does it occur?
It occurs in the fourth as well.
What's that?
11 pi over 6.
Okay, cool. Okay, what else you got? So far they're keeping fairly straightforward. They don't use more than one trig function unless it ends up being the product of two different trig functions. But I haven't seen the one I'm looking for yet, which is a combination of cosine squared and sine, or sine squared and cosine.
Yeah, I don't have any of those yet.
That's
Actually,
fine.
I have a secant and a cosecant.
Okay, let's do those. That's a good one.
Okay, secant x times cosecant x equals 2 cosecant x.
Really? Okay. What's the first step here?
Subtract the cosecant.
Read me the next line.
That's actually it.
Read it to me, because it depends on whether you subtract from the right side or the left side. You can do either one.
The only directions I see right now are solve each equation over 0 to pi by factoring. All answers must be exact in terms of pi.
Okay, read me the next line of this equation. What should it be?
So could I take out a cosecant or should I divide?
Well, you can't divide. That's the thing I'm looking for, is you cannot divide both sides by cosecant x. Why? Because if cosecant x happens to be 0, then you're going to be dividing by 0 and you're going to lose the solution. Remember yesterday when we talked about that?
I can factor one out.
That's the way to do it. In other words, we can go either way, but let's subtract the right side from the left side. This is the proper way to do it. This way we'll find all solutions. And now what?
Then on combine like terms.
No. In other words, you got a cosecant there, you got a cosecant there, we got it equal to 0. What we generally want to do when we have something equal to 0 is turn it into the product of two things. How can I turn that into the product of two things?
Just multiply.
Factor out a cosecant x. You had it in the first place.
Oh, okay. Now I see what you did. Okay, you had to put it on the same side and then you factor.
Yeah,
Okay.
exactly. And you have to put it on the same side before you factor. You can't merely divide by cosecant x. You will, like I said, you just can't do that if there's a possibility that it can be 0. Okay?
Okay, now I see.
Now that you have it factored, what can I say?
Okay, so secant, cosecant x, and secant x equals 0.
So what does this mean? If cosecant x times this quantity equals 0, what two things can I say?
I could say, oh, okay, secant, like, wouldn't you have, like,
Start
secant?
with the left.
Okay. So, like, I would have to find the places where cosecant equals 0. And then where secant
Both of these can be equal to 0. That can be equal to 0. That can be equal to 0. They don't both have to be equal to 0, but one of them has to be. There's no way you multiply two things together and get 0 unless one of them's equal to 0. Okay? So the way we solve this is by setting both of them equal to 0. Well, cosecant x equals 0. Where does that occur?
Cosecant x equals 0. So wouldn't I flip it over and do the inverse?
Well, this is what the cosecant looks like. Where is the cosecant equal to 0? You see anywhere? No, because cosecant has to be above +1 or below -1. So this is an impossibility.
But I have a quick question.
Sure.
So I wouldn't do the inverse and find sine?
Well, okay, but that would mean where is the sine of x equal to infinity, and there's nowhere.
Okay, but could I do it that way as well?
Not really. In other words, this is a harder problem than, it's important to know the relationship between sine and cosecant. Okay, if I draw my sine curve, it looks like this. Okay, notice that the cosecant sits on the peak of the sine and the bottom of the sine, and then just repeats. So the sine has a range between -1 and +1. The cosecant has a range of greater than +1 or less than -1, but nothing else. There's no way that cosecant or secant can be equal to 0 or anything between -1 and 1. And that's an important concept in trig. Get used to that. In the same way that sine cannot be greater than 1 or less than -1, same with cosine. For that same exact reason, cosecant and secant have to both always be greater than 1 or less than -1. So this part has no solution. But this part down here means secant x equals 2. Well, where does that occur? Where is the secant equal to 2? What triangle have I drawn here? This is a 30, 60, 90.
Yes.
So which angle is the secant equal to 2?
The 90 degrees angle.
No.
The 90-degree angle.
Secant is the reciprocal of cosine. So
Okay.
cosine of 60 would be 1 over 2, which means the secant of 60 would be 2 over 1. So x equals 60 degrees or pi over 3.
Okay.
Now, that's only one answer. That's the first quadrant answer. If you need to give an answer in the unit circle, where else is the cosine positive?
5 pi over 3.
Yeah, exactly. You know how to do that good. I'm impressed with that. How you can find the second angle. So here's your, here's your two answers.
Okay.
Both of those, the secant of those angles are equal to 2.
Okay.
Okay. Remember that if we're looking at that 30-60, you don't have to necessarily use the reverse. In other words, as long as you know that it's this, and you know that the secant of 30 degrees would be the reverse of the cosine of 30 degrees, then the secant of 30 has to be 2 over root 3 instead of root 3 over 2. So you can kind of think of those three secondary trig functions in that manner. In other words, figure out what the cosine, sine, and tangent are, and then just take the reciprocal ratio.
Okay.
So we get the secant of 30 degrees is 2 over 1. The cosecant of 30 degrees is, whoops, I got that backwards. The cosecant of 30 degrees is 2 over 1. And the secant of 30 degrees is 2 over root 3. Now, of course, you'd need to rationalize that, but so you'd end up with that. But so the most important thing is you know what your reciprocal relationships are. In other words, what's the reciprocal of sine? What's the reciprocal of cosine? All right, we probably have time for one more. What do you got?
Tangent x cosecant x minus 2 tangent x equals 0.
Okay. Well, what are we going to do here first thing?
Factor out tangent.
Yep. In other words, we're going to make it the product of two things. Once we make it the product of two things, then we can solve it. As long as we have two things being subtracted equal to 0, we can't solve it. But if we get the product of two things, we can solve it. So where is the tangent of x equal to 0? Where does that occur? In the circle.
Sine over cosine.
Well, think of it more along the lines of what's the tangent curve look like?
Pi over 2. Nowhere.
Oh, no, hold on. Right there. The tangent of 0 is 0.
So just
this is minus pi over 2. This is, in other words, the tangent curve has vertical asymptotes that occur every pi. So we have this point where the tangent of that angle is equal to 0, and we also have this point. So x is actually equal to 0 or pi. The tangent of 0 is 0. The tangent of pi is also 0.
Okay.
So we have at least two solutions. And then where is cosecant x equal to 2?
Then I would do sine of 1 over 2.
Correct. Where does that occur?
That occurs pi over 6.
And where else?
5 pi over 6.
5 pi over 6? That we
5.
Yeah, first and second quadrant. In other words, if we're going to use all students take calculus, then this kind of breaks it. Notice that this isn't quite accurate. A means all, but S actually means sine or cosecant. And T means tangent or cotangent. And C means cosine or secant. In other words, if sine is positive, cosecant's positive. If sine is negative, cosecant's negative. The reciprocal has to have the same plus or minus sign on it, by definition.
Okay.
So you can still use all students take calculus to figure out the sign on these secondary trig functions. And in this case, we're looking for where cosecant is positive. So that's the same as looking for where sine is positive, and that's the first and the second quadrant.
Okay. Can you scroll up a little bit, please?
I'm sorry, what? Scroll up a little bit? Yeah.
Yes, please.
And again, you can always view these. I'll actually have this posted on my YouTube channel in probably a couple hours.
Okay, sounds good.
Okay.
Thank you.
All right, Taylor. Talk to you next time.
Sounds good. Talk to you later.